Hello, and welcome to a quick tutorial on how to use BitEscrow. My name's Topher Scott. I'm the CTO. And today we're just going to do a quick run through. I'm going to briefly go over the documentation that we have. And then we're going to dive into the playground, just what this video is about. So to get you guys started, go ahead and open up a browser and navigate to BitEscrow.dev. This is our developer resource site. And right here, you'll dive right into the introduction. So we go over the protocol, how it works, what we're doing. If you'd like to get started with development on BitEscrow, we have a getting started page that walks you step by step through our demo. This is using our client SDK. We also have a testing environment where we have demos, different tests you can do on our API endpoints. So there's a lot of good stuff here. We document all our API interfaces, class interfaces, everything is here. So this is BitEscrow.dev. It's a great resource. Feel free to check it out. But if you look in the top right corner here, we have these additional links. This link goes to our Discord. This link goes to our GitHub. So everything about the protocol is open source. So feel free to check out our GitHub. But then you see this little joystick icon in the corner. And this is what we're going to be going over today. It is the BitEscrow Playground. So what is the Playground? The Playground is a basic front-end application that is, in a sense, it's a free-form contract builder. We designed it as a developer tool, but you can use this tool to build any kind of contract you would like on our platform. And that's what we'll be doing today. I'll be walking you step by step on how to build a contract, how to interact with that contract, invite your friends. You can deliberate on the contract, make it do different things, and then finally settle the contract and somebody will receive some Bitcoin. So let's get started. So first things first, we're going to hit new contract here in the corner. This will bring you to the new contract page. And so basically when you're building a contract, there's two general concepts here. There's a concept of a proposal. This is a document that's going to contain all of the terms in the contract. So here we have a title. Every good contract should have a title. We have a content field that is just open for users to use for whatever they like. You can put anything in this field. We don't really evaluate it for anything. The engine, which you can just leave this alone, but the idea here is that we'll actually have different types of virtual machines that will execute these contracts, and you can choose different virtual machines to run your contract. Also, a chain network. So this is the network that this contract's going to execute on. So currently we're available on MutinyNet, TestNet, SigNet. Those are the three main test networks for Bitcoin. There's actually two different test networks right now, TestNet and TestNet 4. So right now we're on the old testnet, but we will be upgrading to the new testnet, which is testnet 4. But honestly, if you're going to be working with our platform, MutinyNet is the best network to use. It's 30-second blocks. So there's plenty of money in the faucet, so you can get free money to play around with and test things out. So by default, we have MutinyNet selected. And that's the gist of it. That's like the basics that you need for a contract. And then we'll get into these other things: paths, payments, programs, tasks, and terms. So let's first start with paths. So what are we doing here with a contract? Well, we're locking up some Bitcoin, and we're locking up some Bitcoin under some conditions. And so those conditions, we'll go over like the different conditions you can set, but you can also have different outcomes. So what would be an example of a contract with multiple outcomes? Well, we have some example templates up here. So let's go with a very common one, which is a buyer-seller agreement. So you have an agreement between a buyer and a seller. The seller is going to deliver some goods to the buyer, and then the buyer is going to deliver a payment to the seller. And then you'll have some third party that acts as an arbitration in case something goes wrong. Then they can step in and handle a dispute. So we'll start with this type of contract. We actually have a couple different templates to choose from. And so what would happen in a buyer-seller agreement? Well, you would have one outcome, which is that the buyer receives their goods, and so they're happy with their product, and so they're happy with the seller getting paid. And so that could be one outcome for a contract, that the money goes to the seller. Another outcome is that the buyer is unhappy for whatever reason and wants their money back. And that could be something that is handled amicably with the seller, so they both agree, or maybe there's a dispute and a third party has to step in. But the outcome of that would be one way or the other that the buyer gets their funds returned back to them. So those are two different outcomes in a contract. One is the seller getting the funds, and one is the buyer getting the funds. So the way that we would represent that in a contract is using paths. So paths is a way for you to set up different outputs where money can travel, and then labeling that output with a path name. And that becomes something that you can select in the contract where, depending on certain conditions happening, a certain spending path is selected and the money goes in that direction. So we're going to be filling this in later, but that's essentially what paths are. It represents a conditional payment. And so you can set different outputs that the money could take, conditional outputs. But what if there's a payment that you don't want to be conditional, you want it to be unconditional, where no matter what, whether the buyer gets their money back or the seller gets the money, maybe there's some sort of non-refundable payment attached to that. For example, shipping and handling is a common one, where even if the buyer gets a refund, that refund would be minus some non-refundable fee. So you can add that using payments. So payments, it's non-conditional. So anything you put here, that payment is guaranteed regardless of what spending condition might happen. So there's your paths and payments. You have conditional payments, you have non-conditional payments, and then you have programs. So a program is a way to interact with the contract after it's been published. So an example is that you have a program that involves the buyer and the seller. And if the buyer and the seller agree, then they can execute a program that selects a path and closes the contract on that spending path. You can have another program between the buyer and the third party, or the seller and the third party, where the third party can step in and then decide which spending path takes place. So we'll be filling these in later as well.
Great.
Finally, there's tasks. So a task is essentially taking an action in a contract based upon a scheduled time. So when a contract is active, essentially all the funds have been added to a contract, the contract's fully funded, it's considered active, a timer starts running, and based upon how much time has passed, certain actions can be executed automatically within the contract. So one example of this is that you might want to have the contract automatically close on a certain spending path after a certain amount of time, like an expiration date. So let's say that the buyer and the seller have a week to sort of figure out whether, everything's good or there's a dispute. And if nothing happens after that week, let's say the buyer was happy with their product, but they just never come back to our platform. They just decide they're happy, they're not going to follow up, and the seller's just left waiting for a response. Well, you can have some sort of timeout here where you can say, okay, well, after a week has passed, maybe a week is too long, but after a week has passed, the contract will automatically close and send the funds to the seller. So that's where these tasks, these scheduled tasks, become handy. So we have paths, payments, programs, tasks, and then lastly, we have a couple additional terms that are somewhat important. So we have contract duration.
Great.
So this is the maximum duration that a contract can be open. So for example, let's say we have 2 weeks. I believe this is 2 weeks here, or that might be 2 hours. Contract duration is set in seconds. So it's however many seconds you want the duration of the contract to be. So what happens once a contract is past its duration? Well, when a contract goes past its duration, essentially all the funds are released. They're not spent, they're released. So let's go back to the buyer-seller situation. The buyer is putting funds into the contract, and the seller is expecting to get paid. So if the contract reaches its final duration and the contract expires, the buyer's funds are released back to the buyer. And that may not be what you want. You may not want the buyer to get their funds if the contract expires. So that's where tasks would come in handy. You would set a task that says, okay, before we reach this point, we're going to actually close the contract automatically and send the funds to the seller. So that's where a task would be helpful. But if for whatever reason you don't have a task to do that and you just let the contract expire, then the funds will be released and they will typically it goes back to the depositor. So in the buyer-seller case, it would be the buyer. So that's contract duration. We have to have that there because when you deposit funds, these funds are on a time lock and that time lock does expire. So we have to have some sort of max duration here. And that's what that is for. You can also specify a fee rate for the contract. It's optional, but if you don't specify a fee rate, then when you submit a contract to our platform, we'll look at the blockchain and we'll just automatically get a fee rate for you. But if you want to set your own fee rate, you would set it here. And this fee rate would be enforced for anybody looking to deposit funds into the contract. They would deposit enough funds that it would cover the cost of the contract plus the fees. So, and that would be based on the fee rate. You can also set an effective date. So let's say that you have a contract and you're deliberating with friends or associates and you're getting them to fill in the contract, sign on the dotted line, and you collect everything you need. You have a valid contract, but you don't want it to execute right away. You actually want to wait and have it execute at a certain time or a certain date. That would be the effective date. So if there's a specific date you have in mind, then you would set it here. Last but not least, you have funding duration. So when you create a contract and you publish it to our platform, it's available for funding. So once a contract is published, it still needs to be funded. People still need to deposit Bitcoin into escrow in order to fund the contract. So here you can set a funding duration. What this does is it basically says, okay, once the contract is published, you have this amount of time for the funds to be collected and for the contract to be funded. And if the contract is not funded by that time frame, then the contract is canceled, essentially. So this is the funding duration. By default, I believe we have 2 hours here set. Again, this is done in seconds, so it's however many seconds for the amount of time that you want. And yeah, so those are the different options here that you have for setting up what is a proposal. This is the precursor to a contract. And you can see that we have a nice little visual here where we have a payout path and a return path, but it's not here. You don't see it here. And the reason why that is that when we set up this template actually uses a pretty cool feature that we developed specifically for collaborating on contracts. And that is this roles here. So there's this whole other tab that we haven't gone over yet. And that is roles. So the cool thing about roles is that it helps solve a problem with coordinating, not just between different people, but coordinating with their signing devices. Because ultimately, when you interact with our platform and just in general, when you interact with Bitcoin, you have some sort of secret key and you're using that secret key to sign things. And so there's a whole device that custodies your key and manages the way that you use it. So how do you have a signing device that understands a contract? Like, how does your signing device understand what's going on here? And that's why we developed roles. So roles are developed specifically as a format that is easy for a signing device to understand. So a signing device can review the information in a particular role, we call them policies, and then decide, okay, how do I fill out this contract? Like, where do I add funding addresses? Where do I need to sign? Where do I add a public key? So all of this is dictated by roles. Roles are completely optional. You don't have to use them in our protocol. You just have to use the proposal in our protocol. But we added this roles feature so that it's easier for signing devices to be able to coordinate with each other. So when we created this template here, we created 3 different roles. We have a buyer policy, we have a seller policy, and we have an agent policy. And you'll see some similar fields here. We have the paths field, and this is where you see the return path. Okay, so we have a contract. This contract is for 10,000 sats. Is that, 10,000 sats. And we're labeling this the return path. So as a buyer, when you join this contract as the role of a buyer, what you want to see for this contract is a return path. So that is the return path here. Also, programs. So as a buyer, what do we want to see under programs? Well, we want to see the ability to close the contract. We also want to see the ability to close the contract on any spending path. So we're using a format called regex, and this is a developer tool. So if you're wondering, what does this little star character mean? It's a regex thing. If you're not a developer, we will have a version of this that is more palatable for people that are non-developers. But for now, we're using regex for certain things. So you'll kind of see a weird symbol here and there. But this star symbol basically means all paths. So we want to be able to perform a close action, meaning close the contract, on any path that is available in the contract. And the threshold that we need is 2. So we need 2 people to agree to close the contract on any given path. So that's essentially what this program is saying. We also have another program called dispute. And same deal. We want to be able to dispute any path in the contract. Dispute blocks a path from being used. So if a contract normally is going to be paid out to a seller, but you want to block that from happening, then you would raise a dispute. And so generally you can raise a dispute on any path. That's how we have it set up here. But if you want to only raise a dispute on a specific path, then you can actually put the name of the path in here. And then this would be a threshold of 1. So you don't want to require the seller to agree to you to have a dispute. You want to be able to have a dispute, and it should only require your signature to do that. So the reason why we have this under the buyer policy is essentially what this is going to do is that when anybody, whoever is taking the role of the buyer, their signing device is going to look at this and they're going to say, okay, so for this spending path, I need to put an address in here that goes to me. So that's one thing the signing device is going to look at. The next thing the signing device is going to look at is okay, so there's these 2 programs in the contract. I need to make sure that my public key is in this threshold. So there's 2 people that need to agree. My pub key needs to be one of them as the buyer. So that's what these policies are doing. They're setting up just a simple way for a signing device to look at this and say, okay, I need to put an address here. I need to put a pub key there. And as long as I have addresses and where they need to go and pub keys where they need to go, then as a buyer, I know that I am being represented in this contract correctly. So you have something like that for a buyer. You have something like that for a seller. It's kind of the same deal. There's a payout path for the seller. you'll see the same exact programs here. So when somebody joins this contract as a seller, their signing device will go over this, and it'll know where to put addresses, where to put pub keys, how to represent the seller and the contract. And then finally, we have the agent. So the agent isn't getting paid anything here, but the agent does have the ability to resolve a dispute. And you can see that this is the resolve action, can be done on any spending path with a threshold of 1. So you want to make sure that there's only one pub key associated to this program, and it's the pub key that belongs to whoever is the agent or the third party that's involved in the arbitration.
So it's like has all.
So this is designed so that you can hard code this in a website. So you don't need to have this whole form process that you have to go through to fill this out. We're just doing that here because it's a developer tool. So we have to be quite verbose. We have to show you everything that you can do. But if you were a third party and you wanted to run your business on our platform, then you would hard code a lot of this stuff. And then you would only ask your users very simple questions like, where do you want the money to go as a seller? Where do you want the money to go for refunds as a buyer? And everything else you can just kind of fill in the blanks. So we're just being really verbose here because this is a developer tool. It's a free form contract builder. So you got to take the good and the bad with that. But yeah, so that's enough about a new contract. Let's go ahead and just create a new contract. So all the defaults are fine. So we'll just go ahead and hit create draft. Boom. So now we're in the negotiate draft part of this. And this is a bit interesting. So when we were building this developer tool, one of the things we wanted to do was show off how for the negotiation part of a contract, you do not have to involve us at all. So the escrow agent does not need to be involved in negotiation. We can be completely blinded to negotiation. All of this happens outside of the actual escrow protocol. So to demonstrate this, we put together like this really cool old school sneakernet style of just passing links around. So what this weird string that you see up here, what this is this is the contract that we just created. It's been encoded in something called base64. That is to compress the contract data. It's also compatible with your browser. So this can be linked. We can generate a link with this data in the link, and then you can send this link to somebody else. They can click on that link, and then they will see the contract. So we can actually demonstrate this. So let's go ahead and do it. We'll hit share. And there we go. We're back. And this looks kind of weird because we're doing this on one computer, but this could be somebody on their own computer that just clicked on this link and now they're here looking at the contract. So what's happening is all the data that is in this URL up here, if you can see it, all this data is being decoded and then placed in the form, and everything's filled out and ready to go. And you even have the 3 different roles here. So, okay, so this person's going to be our buyer. This person's going to be our seller. Let's add one more here for the agent. It's going to be the third-party arbitration. Okay, so we have 3 tabs open for 3 different users. And we're in this negotiation page, which looks very similar to the new contract page. It's just a couple things that are slightly different. So we can't do anything right now because we actually don't have a signing device set up. So let's go ahead and do that really quick. So in the bottom right corner, you have this little key icon, and this is for your signing device. So we have basically built our own signing device to work with our platform, and it's really neat. It's pretty secure. Our platform's designed for this to be insecure, but we made it secure anyway. So just like a quick intro to our security model here regarding signing devices. The keys that interact with the contract are not the same as the keys that fund the contract. They're distinctly different. So it's okay to have a key pair or a pair of keys that you use to interact with a contract, because that can live in the browser. We encrypt it when it's stored in the browser, but generally you don't want to store keys in the browser because those keys can be associated with your money. We made sure that the keys that you use to interact with the contract are different than the keys that you use to interact with your wallet. So the key that we're going to generate right now for a signing device is going to be strictly for interacting with the contract. It's not going to deal with our funds. In fact, it's going to be a completely different set of keys that you're going to use to fund the contract. So the advantage you have from that is that you can actually have a signing device in the browser and have relative good security assumptions with that, because the keys don't have access to your funds. So let's go ahead and go through this really quick. So there's a couple different ways you can set up a new signing device. You can generate one using BIP39. BIP39 is a way to generate a private key using a list of English words that are very distinct from one another, and they're easy to remember, easy to write down. So we support BIP39 for generating a signing device. So this is one option. You can also import a signing device. So you would do that by importing the secret. And we have a number of different ways you can import a secret. You can import a secret from a BIP32 wallet. For developers that know what that is, it's essentially a lot of wallets that you see that interact with Bitcoin that generate addresses for you. They use this format called BIP32. So you can take a private key from a BIP32 wallet, you can input it here, it'll load it into our platform. You can use just a generic secret phrase. This is probably the most insecure thing to use, and we only have it here for testing purposes, but generally you don't want to use this. But anything you put in here, like we'll put Alice or Bob or Carol, and from that secret phrase, we can generate a secret key, which is not very secret, not secret at all. So again, only use this for testing. If you have a seed, like if you have an actual secret that you want to use, you can input it here encoded as a hexadecimal string. And then finally, if you already have existing words that you want to use, then you can put those in here. Now notice for each one of these options, we ask you for an XPub. And that gets into how we're trying to separate what the signing keys can do versus what your wallet keys can do. So we never ask you for a private key for your wallet. At no point in this protocol do you need to use the private key from your wallet. The way this works is that you generate a signing device. That signing device is going to custody a key pair that interacts with the contract. But when it comes to generating addresses to receive funds, that is going to come from a completely different source. And that source is going to be from an XPub that you provide. This is optional. So if you leave this empty, then it'll just generate an XPub from your signing device. That's perfectly fine too, but for maximum security, you're going to want to have a completely separate XPub from your wallet in cold storage, and that's what you would put here, keeping the signing device for the contract and for your wallet separate. So let's go ahead and just create a new signing device. So also for each of these, it asks you for a password. So this is a password that's used to encrypt your wallet, or I should say your signing device, when it's stored in the browser. So any sensitive information that's stored in the browser is stored encrypted. And the password that it's used to encrypt is what you put in here. So we're going to import a key using the very insecure phrase Alice, and we'll just put the password test. So we're just testing. We hit import, and there we go. So now we've created a signing device. You can see this key is now green. And this is I believe, the public key. It's an excerpt from the public key. And because we didn't specify an XPub, it just generated one for us. And so this is an excerpt from our XPub in our wallet. So yeah, so now we have a signing device here. So now what we can do is we can join the contract. And because we set up these different roles, all we have to do is just hit join, boom, and we're joined. And that's all it takes. So if we were to go and inspect the details of the contract, we'll see there's a return path for the buyer. We joined as the buyer, so this should be here. And there's the amount, and there's an address. So this was generated from the signing device and inserted into the contract. There's no payments, programs. So here are the programs that we're talking about earlier. As you can see, listed as member of this program or both of these programs is the public key for the signing device. So the signing device knew, based upon the role information, that, okay, we need to put an address here, and we need to put our pub key here. And so now we're done. So now we have joined this contract as a buyer, and that's pretty much it. So let's go ahead and repeat this process. So we'll hop over to this tab. So this is going to be the seller. So we'll go ahead and log in, create a signing device. We'll use the very insecure phrase, Bob. And then we're logged in too. So now we're logged in here. However, as you can see, I don't know that Alice joined the contract. So how do we get that information over to here? Well, let's go back to Alice real quick. Let's just copy this string. So this string updates every time we update the contract. So now that we've joined as a buyer for Alice, we can just copy this data from Alice's tab, go over here, hit paste, boom, we pasted it, and now you can see, oh, now we see Alice. Alice is here. So let's go ahead and join as Bob, the seller. So now Bob is joined. And if we do a quick inspection, now we can see that we have this payout path going to an address from Bob's signing device. And you can see that now Bob's key is listed in these two different programs here. All right, so let's keep it rolling. We're going to go ahead and copy this. We're going to bring it over to who we'll call Carol. So Carol's not logged in, so Carol can't do anything. So let's go ahead and create a device for Carol. Carol, import. Here we go. Now Carol can do stuff. So we're going to go ahead and join as the agent. And now this contract is completely filled. So all the roles have been filled. All the information is here. See, everything's filled out. We even have this additional program for Carol to do arbitration stuff. And yeah, everything's good. So now we can move on to endorsements. Endorsements are optional, but they're really handy because they basically signal to everybody else in the contract that everything is good. And you agree that this contract is ready to be published. So I'm going to go ahead and click endorse, and that will add my endorsement. But as you can see, back here as Bob, I don't know that Carol joined, and I don't see Carol's endorsement. So we'll just do the same thing that we did earlier, but in reverse. We'll copy this contract. We'll go to Bob, paste it, boom. Now Bob is up to date. Bob sees everything, and now Bob can endorse. So Bob's going to go ahead and click endorse. He's added his endorsement. So same deal. We'll now copy the updated contract. We'll move over to Alice's tab, paste, and now Alice can see everything's good to go. And go ahead and hit endorse for Alice. And you'll see now that everybody has joined the contract, everybody's endorsed the contract. Now we can publish. Before we do that, I just want to point out one quick thing. So in the top right corner here, we have two different ways you can look at this contract. You can look at it in the pretty looking form view, or you can look at it in pure JSON. So this is what the contract actually looks like underneath the hood. This is the JSON. So you can see we have some members of the contract. We have the actual proposal itself, all the different terms. You can go through all that. And then at the bottom, we have the signatures. These are the endorsements. So just a cool thing to look at. That's what it actually looks like. And then we'll go back to the pretty form view and we'll go ahead and hit publish. So when we hit publish, this is when the escrow agent gets involved. So we're going to take this contract that's still a proposal, but we're going to send it to the escrow server and see if we can get it published. So we'll go ahead and click publish. And there it goes, and boom. So now we have a contract. So this is a contract that's published on the escrow server. So the escrow server is hosting this contract. And yeah, so now we have a whole new page that we need to go through. So yeah, so right now we're awaiting funds. So this is just a contract that's has no funds available to it. But you can look through all the details. Like you can look through, there's a moderator, the pub key of the escrow agent. This is the escrow server, the endorsements from different members. There's all sorts of different stuff that we can go over here, but I'm going to breeze through it just so I can show you how to make a contract. And then you can always go back and look at this stuff. Oh, but this is really handy. So if you look under transaction, you can see some pretty cool information, including these spending path templates. So when we talk about creating different outputs for a contract, this is what they actually look like. So they are different transactions. And when we have funders come in and deposit funds into escrow and lock them to the contract, this is what they're going to be signing. They're going to be signing these transactions that will spend the funds one way or another way. And that's how we keep it non-custodial as well. So everything is pre-signed. So let's go ahead and do that. Let's actually start funding this thing. So we're going to go ahead and under this deposits tab, we're going to make a deposit. And then we go to this whole new page. This is a page for creating a deposit. So in order to create a deposit, you first need to reserve an account. This is a deposit account where the Bitcoin is going to go. And we need to do this step first because there's some information that the escrow agent needs to exchange with someone that's looking to deposit. And so we need to do this exchange first before you can deposit the funds. So what we're going to do is we're going to reach out to the escrow server and we're going to reserve an account. But before we do that, we need a return address just in case something goes wrong and you need to get your funds back. We don't ever want your funds to get stuck in escrow. So worst case scenario, you can always sweep your funds back after a certain amount of time. That's where this time lock comes in. So this is configurable by the server. I forget what I set it to. I think this is 2 weeks. But really this is something that can be changed by the escrow server. This is also dependent on the contract. You can lock up your funds for a really long time. You can lock up your funds for a short amount of time. It's entirely configurable. So by default, I think we just have 2 weeks here. You can also set a fee rate because when you deposit the funds, this requires a transaction. So we have to kind of figure out, okay, what is the fee rate that you want to pay on this deposit transaction? So you can ask it here. You can also use this to sort of adjust when you want or when you expect your transaction to be confirmed. Are you conservative and you don't mind waiting 10 blocks or even 100 blocks? 100 blocks is a little long. Or if you want it right away, it can be the next block. Now, because we're on a test net, there's really no, like all the fees are just 1 sat per VByte. There's no actual fee market on testnet, so it's all the same. But on mainnet, this would actually mean something. We also need to specify a return address. So since we're logged in, we can actually fill this in using our signing device. So there's a little button over here to add a Bitcoin address. Click that, and it will automatically select an address from your signing device and input it here. So that's what we did. That's a return address in case anything goes wrong. Everything else looks good. Also, we are depositing to this particular contract. Now, there are cases where you can make a deposit and you don't necessarily need a contract. You're just making a deposit because you want the funds locked up in escrow. That way, when you do want to lock the funds to the contract, you don't have to wait for your funds to confirm on chain. So this is something that you can take as a prerequisite step if you want your funds confirmed in advance, so that when you do lock your funds to a contract, it's essentially you don't have to wait. It's just immediate. But also you don't have to wait for a confirmation. We do allow you to deposit funds and lock them to a contract while the funds are still unconfirmed. That's perfectly okay. But in some cases, you might not want that for your contract. You might only want people to lock up funds that have already been confirmed. So we support both. But for now, we're going to deposit the funds and lock them to the contract right away. So let's go ahead and click this button to reserve an account. And here we go. So we've been given an address. This is our deposit address here. And yeah, so we have this designed to work with any wallet. So you could scan this QR code with a wallet and deposit funds that way. What we're going to do is we're going to do it the old-fashioned way. We're going to copy the address and we're going to put it in a wallet and we're just going to send funds to that address. The only thing is we're on a test net. So I don't have any money on testnet. You probably don't have any money on testnet. So how do we interact with this contract if we're both broke? Well, one of the cool things about MutinyNet is you have a faucet. And so this faucet will give you free money and we can use that faucet in order to test out the protocol. So I have a handy dandy link here. You can just click on that link and that will take you to the MutinyNet faucet. And how much sats do you want? Well, let's see. We don't want to overspend, so we'll do 10,100 sats. So do 10,100 sats, and we'll put in the address here, and we'll make it rain. Boom. So now the funds are in flight, and this should automatically update once it sees that the transaction is in the mempool. Sometimes it takes a little bit. There it goes. So it sees that the funds are in the mempool and boom. So now we have registered a deposit and that's it. Our funds are registered. And they're also locked to the contract. So if we were to, let's actually view deposit first. Let's see what this looks like. So what this is going to do, oh, actually this might be broken. Oh, it still works. Okay. So you can see some details about your deposit. You can see that the status is the deposit is locked. So the funds have been locked to a contract, meaning that we basically signed the different spending paths in the contract. So that payout path for the seller and the return path for the buyer. So both of those have been signed by the depositor. Depositor deposited funds and then pre-signed these transactions and gave us the signatures to them. So that's what all this information is, but that is how we have a non-custodial lock of the funds that are in escrow.
It is.
So we can't, like as the escrow agent, we can't do anything different than what the depositor has signed and provided to us. All we can do is choose to execute either this path or this path, and that's all we can do. We can't do anything else. So, okay, so we have a deposit. Let's get back to our contract here. You can see that Alice has been busy with different contracts, but this is the one that we want, the one that's still published. And as you can see, the moment we clicked on it, it actually updated and it says, oh, so this contract has been funded and now it's active. So now we have an active contract. It's running. There's our deposit. You can see from Alice from 1 minute ago. You can actually click this link here and it will show us on MutinyNet our deposit. So that's what our deposit looks like, if you're curious. Anyways, So contract is funded. What does that mean? Well, it means that now we can actually interact with this contract. So if you click on the Statements tab, what you'll get is a nice little form where you can execute any one of those programs that you specified in the proposal. So we can do endorse, which is basically signing to have some action taken in the contract. We can choose what action we want to happen. So we have all these different actions available to us. But if we look at the terms of the contract, I don't know if it'll show up here. Maybe not. Oh, these. Yeah. You'll see that, okay, we only specified the close action and the dispute action. So there's actually multiple actions you can take, but you're not going to be allowed to do it because they haven't been specified in the proposal. So this is more of like a UI thing on our end. Even though it's a developer tool, we should probably make it so that this dropdown only shows you actions that you can take. Because if you were to take one of these actions, let's say, I don't know, lock. Actually, I'm not sure if this will work or not, or if this will break the contract, but let's try it. So if we try to take a lock action as Alice, just say testing and hit submit, this should, yep, matching program not found. So basically, there's no program in the proposal that allows us to do this, so we'll just get an error. But what we can do is we can choose to close the contract on the payout path. Let's say we're Alice. We're like, thank you for the widget, Bob. And so we're going to endorse that the contract should be closed on the payout path because we're happy with our widget. We want Bob to get paid. So we're going to hit submit. And now the contract has been updated, as you can see, with a statement from Alice. Thank you for the widget. Alice signed it. And so now that's one of the signatures that we need to close out the contract. So contract's still running, hasn't closed out yet. But now we're going to jump over to Bob over here. And Bob is going to go look at his contracts, see an active contract here. And okay, so we see that Alice has already submitted a statement. Thank you for the widget. She endorsed that the contract should close on a payout for Bob. So now Bob can reciprocate. It's like, okay, thank you, Alice. Please come back for more widgets. And now Bob can do the same thing. He can close the contract on the payout path and hit submit. So that's going to go through. And now you can see that the contract is executed and it's closed. And now it's already been broadcast and we're just waiting for that to confirm. Yeah, so you'll see a nice little history here. And these hashes. So anytime you make a statement to a contract, it goes into a hash chain similar to a blockchain, but specifically just for this contract. And it's a way to cryptographically prove that these statements have been made and they've been made in a particular order. So this goes into the cryptographic proof that proves that the contract settled the way it was supposed to. And so everything is independently verifiable. Like any outside party, given the contract and given the transactions on chain, they can validate that everything was done correctly. So everything can be verified. So we're still waiting for this to close. It's 30-second block times. Yeah, so this contract's pretty much closed. It's been spent. It's in the mempool. We can actually look at the final transaction here. So let's look at it. Yeah, this is what it looks like. So you have an input. This was the input from Alice when she locked up her funds in escrow. So there's that 10,100 sats. And this is the output. It's, this is Bob's address.
All keys.
And that's it. That's what a transaction looks like. You can notice that none of this information about the contract or the details or the statements or any of this other stuff, none of this is visible in the transaction. This is as private as you can get in Bitcoin. Nobody knows what's going on here. It just looks like one random pub key sent money to another random pub key. However, if you're in the contract, then you know exactly what's going on and you can validate everything. And it's settled. So it's done. And yeah, that's about it. So just to review, we created a new contract. We involved some other people in negotiation. We settled on a final contract to propose. You proposed it to the escrow agent. We funded it. We deliberated on it. Everybody was happy. So it's settled. And yeah, Bob got paid. But there's different ways this could have went. Alice could have been unhappy and she could have disputed this, in which case Bob wouldn't be able to close the contract. And Carol would have had to step in and settle the dispute. But yeah, that's about it. If you have any more questions, feel free to reach out on our Discord. We have a link to our Discord here. And feel free to also check out our developer docs. There's a lot of information there as well. Thank you and goodbye.